Okay, sweet. So we are continuing on. I'm gonna redo this question because I don't know if I cut it out of the video or not at the end. But we're continuing on with assignment 6, or chapter 6 assignment rather. So starting off, determine the degree and the value of the y-intercept for the function. So for this, there's two ways you can do it. I'll show the normal way first, which is just expand. So negative 2x squared minus 2x. Because like you just go like that, and then like that. And then negative 2x to the 4th plus 6x squared minus 2x cubed plus 6x. And then the y-intercept is when x equals 0. So x equals 0. Negative 2, 0 to the 4 plus 6 times 0 squared minus 2 times 0 cubed plus 6 times 0. And hopefully you can see where this is going. Everything's multiplied by 0, and so this just equals 0. Another way, the shortcut method of doing this, is you just look at it here, and you know that this 2x, or negative 2x rather, is going to multiply by every term eventually, right? Which means there's not going to be any constant term at the end. It's all going to have at least an x in it, just like what happened, because it's all multiplied by something that has x in it. So you can immediately tell that your end result, without having to know what it is, isn't going to have a constant, which means the y-intercept will be 0. So yeah, that's both ways of approaching it. Oh, sorry, determine the degree. Okay, same thing. The degree can be a shortcut or the normal way. So normal way, we've expanded it. We just look at the highest exponent. Doesn't matter what order it's in, right? This negative 2x to the 4 could be over here. It's still the highest exponent, so it's still 4 as the degree. But we can also just go up here and we count the number of x's. So 1, 2, and then this one is a bit of a trick one, but there's 2 x's in that, so there's 4 total x's. If there was like a plus x squared, we wouldn't go 1, 2, 3, 4, 5, 6, 7, because they're not all multiplying by each other because of this plus here. But because we know everything in the function is multiplying, because there's no plus signs between the brackets, like this is multiplying and this is multiplying, we can just count them. So 1, 2, 3, 4. So the degree will be 4. But honestly, there's no, it doesn't take too long to expand. So expanding just avoids silly mistakes. But with that being said, you can also make silly mistakes while expanding, so there's plus sides and downsides to each of them. So yeah, degree is 4, and the y-intercept is 0. Alright, write a polynomial function that satisfies the following conditions. A, an increasing function with 2 turning points and a y-intercept of negative 2. And B, a parabola that opens up and has 2 x-intercepts. Okay, I don't know what it means by opens up, but anything else? So start with A, that's fine. So what's it asking for? 2 turning points means it's a cubic, and a y-intercept of negative 2 means it gets moved down to negative 2. Okay, so if we just have a cubic and we just make up our own intercept points, right? Let's just say y equals x plus 3, x minus 2, x minus 4. Alright? This will be a cubic function, and it will intercept at -3, 2, and 4. So it'll be like that, sort of. But obviously that doesn't get the interception point that we want, right? That'll intercept at 24, actually. So it's like way up. It'll go like there. But the way that you figure out your intercept is it's always going to be a constant term, right? That's what we just went over up here. In this case, we don't have a constant term. It's just plus 0, so our intercept's 0. So here, what's our constant term going to be? Well, if you multiply all of these numbers inside the bracket with each other, so 3 times -2 times -4, that's going to be the only step of the expansion that doesn't have an x in it. And I can show that by expanding it. So I might just do that to make it more clear. So we have x times x, x times -2, x times 3, and 3 times -2. So we're going to go over into the other working out space a little bit, but I'll erase it once I've proven my point. And then x squared times x is x cubed, x squared times -4, x times x, -6 times x, oh sorry, x times -4, -6 times x, and -6 times -4. And then simplify. That's 10x plus 24. Bam. Okay, so we've expanded it. Hopefully correctly. I'm pretty sure that's correct. And the constant term here is 24, which is what I mentioned earlier. And that's what you get if you do 3 times -2 times -4. So without even expanding the brackets, you can just figure out just by multiplying those three numbers, you can figure out what your constant term is going to be. So with that logic, how do we make something that has the y-intercept of -2? Well, there's a few things that you could do, but the simplest one is if you just have, what are the easiest three numbers to multiply to get -2? Well, if we choose x plus 1, x minus 1, that gets -1, and then x plus 2. So we have 1 times -1 times 2 will get us -2. And this will be a cubic function because, again, we count the x's. 1, 2, 3. It'll have a degree of 3, which means it will have 2 turning points. So if we graph that, we'd go bang, bang, intercepts at -2, intercepts at -1, and intercepts at 1. So it'll go up, down, and back up again. And this does realistically look like it could be -2. And we know it's -2 because our constant term at the end of the expansion would also equal -2. So hopefully that was a clear enough explanation. But that's the way you would craft it for anything. So just to give another example, let's say we want it to be, I don't know, 28. Again, a few different combinations you could do, but let's not overcomplicate it. If you just go x plus 2 times x plus 2, that's 4 times x plus 7, and you graph it, it'll come up like this, -7 will be down here, -2 will be up here, come up like this, come through, bounce, and then go up. And we've got a turning point there, we've got a turning point there, and then it'll go all the way up, and this will be 28 that intercepts at. So, yeah, hopefully that makes sense. In case you don't understand the bounce, it's because this is like squared. If the point repeats like that. I haven't seen it in any of the questions, so I won't go too far into it. But then it bounces instead of crossing through. Because the way that I like to remember it is just think like, oh, it's intercepting, but it's intercepting again super quickly because it's going through the same point. Okay, so go back and write our original answer down and then move on. X plus 1, x minus 1, x plus 2. Sweet. And next one, all right. A parabola that opens. Oh, okay. Also, I'll just mention quickly. Increasing just means that it has to be positive, right? It has to go from the third quadrant up to the first quadrant. It's not going like this. That's all. A parabola opens up and has two x-intercepts. Okay, that opens up. I'm not entirely sure what that's trying to say. So I'm just quickly going to pull up the answers. I have not heard that terminology before. Home. Shared with me. Sorry for the delay. I should have read through this first, but I figured I'd go alright. Yeah, it really is just this terminology that throws me off. That opens up. Okay. So I guess it's just any parabola, I assume. So a parabola means that it has a degree of 2, right? And it's going to either be a smiley face shape or an upside down face shape. But for it to have two x-intercepts, it can't bounce. So like up here, how we earlier talked about it bouncing, I was like, oh yeah, it'll bounce there and go up. If it bounces, that doesn't count as having two x-intercepts, right? That'll just be one for a parabola. So if we have it just go through and this bounces at the origin, that's not going to have the two x-intercepts that we want. And if we move it up from there, right, if we go here, it has 0 x-intercepts. So what we really need is either have an upside down smiley face, like this, and then move it up, so that it goes like this, and then you can see it clearly goes through 2 points. Or the much simpler way of doing it is taking our right way up smiley face, which we have like that, and then just moving it down. And then it has 2 x-intercepts that way. So we'll start off with our basic parabola formula. So y equals x squared. And we can move it down. This could be -1. It could be -2. It could actually be -0.001. But either way, as long as it's a tiny bit below, it'll have a point here and a point here that it intercepts the x-axis at. But the answer works perfectly fine, so we'll just stick with that to not confuse anyone. F of x equals x squared minus 3. And that'll bring us down to -3, because that's our constant term once again. And it'll go like this, and it'll have 2 interception points there. Perfect. So just chuck that in our answer over here, and we can move on. I still don't know what it meant by opens up. It might mean like it doesn't want it to be upside down like that. But yeah, maybe ask your teacher about that one. I've never seen that before. All right, consider the following data. Blah blah blah. Use technology to graph the data as a scatter plot. Okay. We can do that. Determine the polynomial regression equation that models the data. Okay. And then use your equation to determine the height of the pebble at 1.25 seconds. Alright, so we'll start off by just pulling up the data, I suppose. Desmos. Also, good work on figuring out question 3. I somehow did not figure out that it just had to be a linear regression line. So this is 0, 0 0.5, 1, 1.2, 1.52. Sweet. And then this is 30, 28.77, oh, sorry, 28.77, 25.11, 22.97, 18.98, and finally 10.42. And then here, it's pretty much second nature for you now, with all the practice that you've been doing. Bam, y1, tilde. And also, actually, it didn't tell us what to do now, so I'll just talk you through this. We've got our points here, and it is a shame that I can't draw on the screen. I might actually just come back to this. So we had our points, and they were sort of like this, right? Going down like a downward slope. So you can sort of say it looks like that, and if you draw the full thing, that just looks like a parabola. So based on the shape, I'm just going to immediately assume that it's a parabolic regression line. So you know how we have to put our general form in here? The parabola, it's going to look like ax1 squared plus bx1 plus c. And it fits nicely through all of those points there. And then it asked for the pebble at 1.25. So we'll put y equals, x equals 1.25. And that's 22.356. We'll just round that up, 22.36. I know I skipped a couple questions there, don't worry, I'll come back. 22.36. Okay, so for A, it says provide a sketch. I guess I did that, like this is a sketch of it. I don't know if that's actually what they want. And then on the answer key here, they put the domain and range, but it doesn't ask for that here. So I'm not sure what they put that there for. But maybe you need that. Put that just in case, I guess. I've taught you how to do that before. B, determine the polynomial regression equation. So you grab your numbers from here. So A is negative 4.90172. B equals 0.0145814. And just once again, I'm pulling these numbers from down here when it says parameters. 29.9968. And then y ax1 squared plus bx1 plus c. Sweet. And then D, when does the pebble hit the river? Okay, so we're trying to figure out when y becomes 0, because that's when the pebble hits the river. So down here, that point, 2.475, and it says the nearest hundredth of a second. So we'll just put this down first. Oh, that was a weird 5. Okay, so this is tenths, this is hundredths, this is thousandths. So they want it in this spot here. So we round up 2.48 seconds. Too easy. Oh, and this has to be meters. Okay, nice. Now we move on. Consider the following data. Okay, I'm going to start graphing this before anything else, because that's what takes me the most amount of time usually. Oh, whoops. Actually, I don't know if it'll be polynomial again yet, so I won't bother bringing that back. This, I think, will faster if I just do that. Okay, x1, 0, 1, 2, 5, 6, 7 and negative 43, negative 44, negative 46, negative 46, negative 48, negative 47, negative 50, and negative 51. Perfect. And let's just press our magnifying glass once again. Okay, this looks pretty linear. Y1 equals A x1 plus B, and this should fit nicely. Oh, what have I done? Oh, equals, whoops, I keep doing this. Tilde, bang. Okay, that is my bad. But we got there in the end, and that does fit very nicely. Okay, now the first question says, provide a sketch, like, I don't know. I don't know what it wants, something like that. Oh wow, okay, it says negative half a mark if it's missing the domain and range, so I guess we'll start having to put that in. In this case, wait, they've just chucked random things. I guess just like go up and down to the nearest tens. Did they do it on the previous answer? No, they didn't. Okay, well, whatever. They've done from 0 to 10, so. Does it intercept at 10? No. Yeah, I don't know. Right now, this is confusing. Oh yeah, it's down here, that's why. Okay. Sorry, I'm wasting time. This domain and range stuff, I guess just make sure it encompasses the data. I don't really see how they're figuring out what it's supposed to be. Does it say anything here? No, it doesn't say anything on the data, on Desmos, so yeah. Not too sure about that, my apologies. Determine a linear regression equation, we've got that. Our A is negative 1.083333. Our B is negative 43. Okay, so you're right. Y equals negative 1.08333x minus 43.0833. Again, pulling those numbers from the same place down here, and then you plug them into this function up here. And then estimate the y value when x equals 1.5. Come over here. Okay, I'm being called for dinner, so I'll finish this video, but I'll splice it together so it's in the same thing. Don't even stress. When does this intercept? Negative 44.708. And they've just rounded that up because it says estimate, so it doesn't have to be exact. They've just rounded up to 45, negative 45 rather. And when y equals negative 60, exact same thing, you just plug it in here. Whoa. Y equals negative 60. And then, where is that? Oh, down here. And you find the interception point. Excuse me? Okay, it's not showing me when they intercept. 15.615. Usually it puts a dot there, but whatever. And again, it says estimate, so we'll just round up. 16. Sweet. Okay, and we've only got a few left to go. So I'll finish that after dinner. 1 second. Okay, we have finished dinner. It was actually really nice. It was steak with potatoes and a bit of salad on the side. And now we have to continue with this. I just realized my previous video is 24 minutes, so I got to speed up through this. Alright, so it's another Desmos one. Gotta go quick. 0, 2, 3, 3, 6, 8, 11, 12. 0, 2, 3, 3, 6, 6, 8, 11, 12, and then I should have just started a new one. Oh my goodness. I wonder if this is what takes the majority of the time on the videos, because I don't know how I take 24 minutes to go through the couple questions. Okay, 18.5. Hopefully the next one isn't another graph on Desmos one. 31.3. I don't mind these, it's just they take so much longer. 41.5, 45, 48.3, and 49.1. Oh, sweet. And look at that, and then this says use a cubic regression model. So AX, oh my word, we'll just start again. Y1 is AX1 cubed plus BX1 squared plus CX plus D. Oh, CX what? 1 plus D. Perfect. And that fits it very nicely. What do you know? Once again, they've, for some reason, got the range and domain there. Still can't figure out what they do for their domain and range, but maybe they just pick whatever domain they want, and then no, but the max is still, that's what confuses me. The max of this is 48.95, and then their range says up to 60, so I don't know. You'll have to figure that one out, but we can do the rest of it. This is just copying down all the numbers. 0.00 2 1 3 3 5 5 x cubed minus 0.24835 x squared. Whoops. What were the other numbers? 5.229 plus and then plus 18.2234. Sweet. Estimate when x equals 5. When x equals 5, we'll zoom in. Rough estimate. It's about 38. Actually, I don't know how many decimal places they want, so I'll do it properly. Don't be lazy. 38.427. Okay, so about 38.4. And then the x value and y is 40. Values in the question, so I'm assuming there might be two different options because it's parabolic. Oh, because it's quartic. Cubic? Oh my word, I can't speak properly. When y equals 40 and 20.246 or 565. Wait. Let's just zoom out just in case, because it is cubic. Oh, bang. Yeah, there is another one. Okay, so 90.593 is the third one. So x1 equals also on all these I said provide the Desmos functions used. So like we put in x equals 5, and here we put in y equals 40, and here we use like y 1ax cubed plus bx squared x1 x1 x1. Sweet. And then this is just an estimation, so x1 equals 6, x2, this is just rounding, 20, and x3 equals 91. Perfect. Moving on. Oh, we've got another Desmos one. Okay. You specifically asked, I think, from 2 to 6. So I'll do this one as well. Is 7 the same? Oh, this is the last one. Okay. I may as well then. 11, 20, 24, 28, 27, 33, 17, 38. Okay. I will not repeat my mistakes. We will restart from fresh. 11, 20, 24, 28, 27. I like almost lose my train of thought doing this. Okay, 17. And then it was 38. I think that's it. Goals. 2, 1, 2, 0, 3, 2, 3, 1, 4. This should be a lot faster for you, I'm assuming, because you won't have to remember the numbers. You'll have the paper in front of you and the laptop open separately. And draw a line of best fit for the data. Okay, perfect. So we do our regression line. It looks pretty linear with one outlier, so I'm just going to draw a linear one. y1 ax1 plus b. Sweet. And use the graph to determine the number of shots to require 3 goals. To score 3 goals. Oh, whoops. Okay, so sketching it, it was like in pairs going up. One at the top and one down here, I think. Yep. And then line of best fit goes through like there. This is just a sketch. And then use your graph to determine the number of shots required. Oh wait, there's a 0, so let's just put this on the 0 because of that 0 up there. Number of shots required to score 3 goals. Okay. So goals is our y-axis. So we let y equal 3. Y equals 3. 33 point. Why isn't it showing the actual? Oh, there we go. 33.463. So you need more than 33 shots. So even though like this is a 4 here, if you use real world logic, like you can't score 33.463. But if you've scored 33 on average, you have. Oh, sorry. If you've taken 33 shots, you on average haven't scored your 3 goals yet. So you need 34 shots required. So for all of these ones, when we were estimating, we rounded up, like that to that, that to that, that to that. It's all just rounding up. Just round normally because this goes down. But then for real world ones, you have to think like realistically. Like let's say, I don't know, on average, out of every 10 people, 3 people will have a birthday on the same day of the week. Alright? How many people do you need to have 3 people share the same birthday? Oh, sorry, if it was like 10.46. You can't have 10 people because that's under the required amount, right? That'll equal to like 8 something on average. But if you want 3, if you go to 11, then it'll be 3 point something something. So you'll have crossed that threshold. So you just need to think like we round up in these sort of circumstances. A good key word is like required to. Then you just go up to be safe. You always round up instead of down. And that's it. And we'll mark the work. You're going to end up with this. And this. And this. So we'll just highlight those. I believe in you, Nixon. You got this.